C. Calculation analysis of the results. Let's carry out the calculations for the influences of harmonic oscillation, random oscillation, single pulse shock, multiple shock, linear acceleration, and acoustic noise. So now we can carry out calculations for thermal influence, a stationary thermal mode. So let's start the post-processor and see the modeling results. So let's deduce the harmonic oscillation, frequency dependence of acceleration amplitude at the checkpoint. We determine resonance frequencies. So we choose resonance frequency 160 Hz. Let's deduce acceleration fields for the given frequency both in 3D and on the plane. Next, we deduce accelerations at each radio element and compare the results with the maximum tolerable values, and we could make conclusions about probable failures. Similarly, it is possible to deduce fields of deflections, displacement, stresses, mechanical load, and overload factors of radio elements. So, for example, we could deduce a field of stress, shift of spot of printed circuit assembly. And we can see the results in 3D and 2D. All received results are included into the report by pressing the special Save button. So let's turn to random oscillation. The field of mean square acceleration, both 3D and on the plane. Also, acceleration at each radio element and compare with maximum tolerable values is possible. So we make conclusions about probable failures. Also, similarly, it is possible to deduce the field of mean square deflections, displacement stresses, mechanical load, and overload factors for radio elements. For example, we shall deduce overload of radio elements. So here we see there are no overloads. So all received results could be included into the report by pressing the special Save button. At a single shock, let's deduce time dependence of acceleration at the checkpoint. So we deduce acceleration fields during this set moment of time, both in 3D and on the plane. So let's choose 2.05 milliseconds. So we could see the result in 2 and 3D. Also, we could deduce acceleration at each radio element and compare with maximum tolerable values. And we could make conclusions about probable values. And similarly, it's possible to deduce fields of deflections, displacement, stresses, mechanical load, and overload factors. So we see the result in 3D and in 2D dimension. So at acoustic noise, we could have the next results. Frequency dependence of acceleration amplitude at the checkpoint. We could choose the resonance frequencies in 2 and 3D. So we choose resonance frequency, and we deduce acceleration fields in 3D and on the plane. So also we could deduce accelerations at each radio element and compare with maximum tolerable values. And similarly, it's possible to deduce fields of deflection, displacement, stress, mechanical load, and overload, and save the results. So a stationary thermal influence, a field of temperatures both in 3D and on the plane. So we can see now the most heat elements, and on the plane the same picture. Also, we could deduce temperatures at each radio element and compare with maximum tolerable values, and then make conclusions about probable failures. And similarly, it's possible to deduce thermal load and overload factors of radio elements. And all received results we could save by pushing the special save button.